Alright, here we are with Math 1 Features of Functions. Okay. Now, just a reminder that the rate of change, positive and negative, we don't need to deal with those, but I am going to do them anyway on here when we talk about the key characteristics, just because we can, so you can kind of see what it would be. Alright, so we'll start off with domain. So remember, domain, range, positive, negative, increasing, decreasing, all deal with that interval notation. So on all of them except for the range, we use the x values. So domain is where my graph exists. So it starts, the furthest left it goes is -4, and then it's continuous till we get to 5. So my domain is -4 to 5. That's where it exists on the x-axis. For my range, I just go on the y-axis, how low it goes, -5. And it's continuous up to the highest point of 7, so -5 and 7. Okay. Interestingly enough, with that range, I can see that lowest and highest point pretty easily, and so I know that my highest point, my maximum, is going to be 0, 7, and my minimum is going to be 5, -5. Okay, so as I do the range, I can kind of see those pretty easily. Okay. Then we've got our increasing and decreasing. So we always look left to right, so it's increasing as we go left to right. So from -4 to 0, it's increasing. Then the rest of the way, it's decreasing. So it'll start decreasing at 0 until we get to x equals 5. Okay? Now, I should have also noticed my y-intercept, which is right there at 0, 7. My maximum is also my y-intercept, and that can happen. Now, for positive and negative. Positive is simply when it's above the x-axis. So, starting here on the left, until I get right here to my x-intercept, so x-intercept of 0, 3, that's the point where it changes. So, positive is from -4 till positive 3. Negative then starts at that positive 3 to the end of my graph. So it would go from 3 to 5. Okay? And that's all I do with positive and negative. Now, my rate of change, they give me the interval -2 to 0. So at -2 I find my graph, and at 0 I find my graph, and then I find the slope. So I'd go up 2 to the right 2. So 2 over 2 would be reduced to 1. So my rate of change is 1. Alright, well that's all we got to do on these guys, so let's keep going. Okay, so start off again with domain. So there's points here, not arrows, so I know that I start at -6 and I end at +6. So -6 to 6 is my domain. Okay, for my decreasing, we decrease till we get to that minimum of -2. So I go from -6 to -2. So my minimum is -2, -3. Okay. Then it's increasing from -2 till we get to 6. And that just so happens to be my maximum up there at 6, 5. Okay. For my range then, I go from -3 clear up to 5, right? -3 to 5. For positive, when is the graph above the x-axis? Well, if I look at those two x-intercepts, that's going to be where they change, right? So x-intercept at -5, 0, and at 1, 0. So it's positive from -6 to -5. Then remember, we use that u. So that's that section of the graph. Then from 1 to 6, it's positive again. So my negative then goes from -5 to 1 when it's below the x-axis. Then finally, my y-intercept is right there at -1. So 0, -1. And then for my rate of change, I'm going from -6, so right here, +2, so right there, which I don't go up or down, so my rate of change is 0. All right, there's graph number 2. Okay, graph number 3. Now, I don't think it shows up, but we probably should put some arrows here so we can see those examples. Okay, so if I have the arrows, it means the graph is going to keep going to the right and keep going up, and going to the left and keep going down. Okay, so my domain would keep going to the left. We call that negative infinity. To the right, we call that positive infinity. So it'd be negative infinity to positive infinity. For my range, it's going to keep going down. We call that negative infinity. And it'll keep going up. So we call that positive infinity. Okay. Now, because it keeps going up or down, technically we don't have a maximum or a minimum. Okay. Though we could argue that these are the relative maximums and minimums right here. Okay. So if we put something like 0, 2 for our maximum, and looks like 1, so 1, negative 2 is our minimum, I probably wouldn't get too upset about that. Okay. Alright, X-intercepts, we can see there's 3 of them, right here, here, and here. So this is at 0.5, 0. This one would be about 0.4, negative 0.40. And then this one would be 1, 1, 1, 2, 1, 3, about 1.4. Yours are slightly different, that's alright for our x-intercepts. Okay. Y-intercept at 0. Oh, why am I looking at that? That's not the y-axis. Would be up there at positive 2. So 0, 2. Okay. Positive and negative, increasing and decreasing. Okay. So positive would be from here to here, and then here up. So positive would go from that 0.4, negative 0.4, to 0.5. Then we'd jump and we'd go from that 1.4 to, and if it keeps going, it would go to infinity. Okay. For the negative, we'd start out at negative infinity, because that keeps going, till we get to the negative 0.4, and then we do the jump, and it would go from 0.5 to 1.4. Okay. So notice these x-intercept numbers here, we're seeing them up here as well, because that's where they change. Okay. Increasing, well, it starts out here at negative infinity and it increases till we get up to that maximum. So negative infinity till we get up to the next value of 0. Then we jump, and at this minimum, it goes up. So minimum would be at 1 to positive infinity. Again, first let's do so decreasing would be from here to there. So from 0 to 1. So the max and minimums, when we normally have them, okay, we can see that those numbers are showing up in our increasing and decreasing. So they are connected in a lot of ways. Then finally that rate of change from negative 2 to 2. Okay, well, we don't know what negative 2 is at, do we? So we can't really do that one. I wonder if they meant from 0 to 1. That's probably what they meant. So if we did that, we'd go down 1, 2, 3, 4, so negative 4. To the right, 1, actually 1, right? Because that's 0.5. So it'd be negative 4 over 1, which is just negative 4. All right, number 4. Domain, well, we start out at 0. We keep going until we get to 13. Range, our lowest is here at 1. And our highest is up at 11, so 1 to 11. Which means our maximum is going to have not 11, 10. Don't make that mistake. Our maximum is going to have the point x value of 10, y value of 11. Oh wait, no, I was right. That's when we use the y values. So our minimum is going to be at 1, 2, 3, and 1. Okay, which, if we're talking about the increasing and decreasing, we can then use those numbers, right? So I know it's going to start out decreasing at 0 till we hit that minimum, which is at 3. And then it's going to increase from that 3 till we hit our maximum of 10. Okay, and then we decrease again from that 10 till we get to the 13. Okay. Now for negative, there's nothing here. So there is no negatives, which you could do the empty set to represent that. So that means for positive, it's the same as the domain. Okay, which means there are no x-intercepts. Again, you could use the empty set there. And for y-intercepts, we see it at 10. So 0, 10. And then finally, rate of change from negative 6 to 6. Again, there's no negative 6. So where did that come from? We'll say 0 to 6. So 0 would be here at 10. 6 would be right here. And we'd have a rate of change of 0. Alright, so there's all our graphs. Now let's look at the tables. Okay. So rate of change of negative 2 to 2. Negative 2 to 2. That would go up by 4. Negative 5 to 5 would go up by 10. So it would be 10 over 4, which would reduce to 5 over 2. Or 2.5. Either one. Okay. Got that one out of the way. Now, for the domain, we just do all the x values. They're in order, so we're just going to say negative 2 to 4. Now, we could just list every single one of these numbers and call it good as well, because we don't know if this table is continuous or discrete. Technically, if it's just a table, we should probably write them all out, but I prefer that we just do the negative 2 to the 4. Okay, range now. We look what's our lowest number, negative 5, so it starts at negative 5. It's our highest, positive 5, and it goes to positive 5. So that keys us into our minimum and our maximum, doesn't it? Because our maximum is going to be highest point, 2, 5, and I wrote it in the wrong place, didn't I? And our minimum is going to be that point, negative 2, negative 5. Okay. Our y-intercept, we look where x is 0, and it's 0, 2. Our x-intercept, we look where y is 0, and it's negative 1, 0. And that's going to help us with our positive and negative, okay? Because before that, we're in the negative. So negative would be from negative 2 to negative 1, because again, we use the x values for our interval notation. And the positive is going to then be from that negative 1 all the way to 4. Okay. Now, for increasing and decreasing, all we do is take a look at our numbers. Say from negative 5 to 0, we're increasing. To 2, increase. To 3, increase. To 5, we're increasing. Then we're not increasing anymore. So I go from negative 2 to 2, we are increasing. Then for decreasing, 5 to 4, 4 to 2, so from that 2 to 4 is where we're decreasing. And there's our first table. Okay, we do our next table. I want to double check to make sure those are in order. They are, so I don't need to adjust anything. So domain goes from negative 6 to positive 6. Our range goes from highest number, which is 20, to lowest, which is 0. So 0 to 20. Right? Always low, then high. Which means we have no negative numbers, so there are none. Okay? So our positive is the same as our domain. Okay? Now, y-intercepts, we look for zeros. Okay? X of 0, there's our y-intercept, 0, 5. Y of 0, there's our x-intercept. So 2, 0. Maximum, where's our highest point? It's at 20, so negative 6 to 20. Then our minimum, our lowest number, 0, so 2, 0. Okay, then we take a look at where it's increasing and decreasing. So 20 to 15, decreasing, 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 decreasing. Then we increase and increase. So we're increasing from 2 to 6 and decreasing from -6 to 2. Rate of change from -6 to +6. So we add 12 to do that, 20 to 4. That would be, we subtract 16. So -16 over -12 would be -4 over 3. Now, a thing to remember is domain, range, positive, negative, increasing, decreasing. Those are all interval notation. That's why we use the brackets. For y, x, max, and mins, those are points. That's why we use the parentheses. Okay? All right, 2 more tables to go. So, domain, -3 to 6. And all the numbers in between. Range, our lowest again is 0. Highest is 100. 0 to 100. Our y-intercept, we have x equals 0 at 25, so 0, 25. Our x-intercept, 2, 0. 0 is also our minimum, so 2, 0 would be our minimum. 100 is our maximum, so -3, 100 would be our maximum. Okay. Is it increasing anywhere? I'll decrease, 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 increase, decrease. So from 2 to 5 is the only place where it's increasing. For decreasing, we start at -3 to 2. Then we jump and go from 5 to 6. Okay, none of these are negative, which means our positive is -3, 6, and our negative is the empty set. Then rate of change of -3 to -2. So we add 1, go up 1, but down 5, so the rate of change would be -50. All right, last one. Okay. Again, we check to make sure the order is right. It is, so domain 0 to 6. Okay, our rate of change 2 to 5. So we would add 3 to get from 2 to 5. 9 to 81. We would add 72. So 72 over 3, which would give us 36. No, that's 2. Would give us 24. Okay. Our range, our lowest number is 0. Our highest number is 729. So our minimum is going to be 0, 0. Our maximum is going to be 6, 729. It also tells us 0, 0. That's both an y-intercept and an x-intercept. Okay. Increasing from 0, it keeps increasing, so it's increasing the whole time, which means it's decreasing none of the time. It's also not ever negative, and that makes it always positive. So 0 to 6. All right, there we go, guys. So there's the main things we need, and again, the ones we needed to focus on, domain and range, increasing and decreasing, are interval ones, as well as y, x, max, and min are points. Okay, so we should be good to go and be able to spot these key characteristics of these functions, their features, on tables and also on graphs. Okay, all right, guys, there we go.